8.5, factoring the differences of squares. And you've already done this, so this is basically the same thing. So if you have a squared minus b squared, then that'll factor back to being a plus b times a minus b. Yeah, so make sure that gets in that box. And an example of that might just be, if you have x squared minus 9, it would be x plus 3 in parentheses times x minus 3. And we've already done these problems, but we've been going from there to there, as opposed to the direction that now you're going to be factoring these. So earlier you would have kind of distributed, but now you're factoring. So factor each binomial, and I can just kind of see these. And the more you do them, the more you can see them. So here's n squared minus 25, and we'll rewrite it. But that basically means that matching the formula, instead of having a squared, you'd have n, so n would be the first two things to show up. And instead of having just 25, this would be b squared, so that means that b would have to be 5. So jumping back and forth between the formula, you'd have n plus 5 times n minus 5. And of course you could write that as n minus 5 times n plus 5. But I usually, and most people, like to see the plus sign written first. I only mention that because if you were to go to the formula, you would probably see or a minus b times a plus b. And it's really just kind of unnecessary to bog you down with memorizing that as two different formulas. So move on to number 2. And just the same with any factoring problem, you could FOIL this out just to convince yourself on these early problems that these will work out this way. Then we got 36x squared minus 49y to the 4th. So rewrite the problem. And even though it looks different and peculiar, you would know that a would be 6x. These are always going to be plus and minus. And then b would be 7y, not to the first degree, but squared. So here's 7y squared, 7y squared. Notice that all of these have minus signs. If they were plus signs, you couldn't factor them nicely for now. 3 has a little added on step, so you can either work in columns or keep on going down. 48a cubed minus 12a. Sorry about the plane in the background. Now I look at this and I see that, well, this doesn't look like the perfect squared problems, but I could probably pull greatest common factors out first. And I look at 12 and I look at 48, and 12 goes into both of those. And then I look at a cubed and I look at a, so I could factor out a from both of these terms. So then I'll open up parentheses, which means I have a squared minus 1. And once I've done that, I keep on rewriting what already has been factored out at each step along the way, and I see that this would be a plus 1 times a minus 1. I'm of the opinion that the remainder of these are mostly on your own problems, but for 4, I'll show you how I would do this. I would probably rather factor out a negative first, leaving me with t squared minus 81, and then I'd have negative t plus 9, and then t minus 9. The reason I like that is that's a more common way that we see these. I also really prefer not to have negatives in front of the variable, so that's how I would do that one. 64 is pretty, number 5 is pretty straightforward. You can Wolfram Alpha that after you're done. 6 is similar to 3. So let's check out 7 before I move on. So here's 7. Go ahead and pause this, do those other problems, and try this one on your own. Okay, so hopefully you've paused this and done those other ones, and you can even try this one first. So here's negative 4y cubed plus 9y. Let's pull out the greatest common factor of both of these. Now in factored form, it's more common to get the negative outside. So here's negative 4y coming out. leaving us with y squared. Oh, can't really do anything here, right? I think that if I factored out 4 from this, having 9/4 would make it ugly. So go ahead and erase that. Let's go back, and let's only pull out negative y. This would leave me with 4y squared minus 9y. The more you do these, the more patterns you'll be able to find and to see how you ended up kind of making a bad judgment like I did there. I caught that earlier than you might, because I've done more of these. So here's 4y squared minus 9y, and I see that the left forms a nice and perfect square. And I also see that the right, speaking of mistakes, look at me going again. Jeez, idiot. Sorry about that. So 2y ended up there, and then I'd have a plus 3, and then a 2y minus 3. So sorry about the error on my part there, but I think that based on this being so similar to the other problems, other than just pulling this out, I think you'd be fine there. You know, this says apply a factoring technique more than once. So this is where some flexibility is helpful. Okay, so look at number 1. X to the 4th minus 81. And when I go to factor this, I'm like, oh, that's a perfect square, where I have x squared plus 9, and then I have x squared minus 9. Now looking on the left, x squared plus 9, you might want to write that as something, but the formula only works when it's a subtraction symbol. So I can't apply the formula here. I could later do this with, the square root of negative numbers, but that's not happening yet with the math that we're doing. Because of that, I can only rewrite x squared plus 9 all over again. Now, in blue, I've retraced x squared minus 9 because this is another perfect square. So if I factor this out, I'll have x plus 3 times x minus 3, and we'll box this as complete. And it's complete because I've already talked about that being unfactorable for now. And it's also nice because here's my highest degree showing up, and we're still even trying to stick to our normal rules of writing that business from left to right. Number 2, super similar. I'm going to put the answer up in just a moment, so pause the video and do this OYO. Alright, I didn't show my work, but if that matches what you got, you're good to move on. And then we'll take a look at number 3, I guess. Okay, now this is always kind of one of those deals where if you dislike A and B, you could replace that with X and B with Y. I usually have a easier time letting those stand apart. So let's see. Problem 3 says 4a to the 4th minus 4b to the 4th. And I look at them and I'm like, oh, cool, maybe I can pull out 4a. But I have to be cautious because I can only pull out 4. Here's a to the 4th minus b to the 4th. We factored out a 4 to start. Now, I recognize this is a perfect square. So I'm going to write a squared plus b squared times a squared minus b squared. And then going from there, I can do 4 times a squared plus b squared. I can't do anything with that for the same reasons as earlier. But then a squared minus b squared becomes a plus b times a minus b. And then this would be completely factored. Now here we got apply several factoring techniques. We'll save that for another video. So for now, this is just those first types of problems in this section.